Hey guys, Scott here again today. Right, so this particular video I'm going to show you today is a workflow that a customer of ours asked me if it was possible or not. So the problem is the reality of the world, right? Customer sends you a drawing, it's been drawn on the back of a fag packet, or a napkin, it's been photographed or scanned and sent through to you, or it was even at worst it was a CAD drawing that they've scanned and then sent through to you, so you can't reuse any of the geometry. They won't send you another copy of it that's usable, so you end up with something like this, right? All's well and good. All the dimensions are there. This is just a simple 10mm plate with a whole bunch of holes in it, and you've got to get them in the right place. So how do you go about it? Right. So in Fusion, you start drawing something up, and let's call it 500 by 600. And we extrude it out 10mm, and we start needing to position some holes. Seems pretty straightforward, so you can access the hole command from down here or press H, and it's going to ask you a couple of options here: at point, or so you can create one hole at a time, or multiple holes based on a sketch. So let's just do the first one, and we want it to be 20mm diameter. Oh, just hit enter there. So that was at some random positions. Let's edit that and select some references. So we want that to be 90mm away from that edge and 120 away from that edge. That's fine, right? That's cool, but there's going to be a whole lot of hole features all the way along here, and not all the dimensions you've been given are from the edge. So sometimes they're offset from that, so you'd have to create a formula, add that to that. As an example, we could create another hole again. Let's repeat the command and go from, again, that face there, this edge, 90 plus 40, and then from that edge again, 120. So that's cool. They're in alignment with each other because we've typed in that dimension, but what happens if the dimension changes? You've got to go through and reposition the hole on each one of those holes. So it's really kind of clunky, not the best situation. So let's just roll this right the way back and delete that. Now how about a different approach? Let's create a sketch. We've got a PDF, so why not use it? So I took a screenshot of it so I can create and attach it to the canvas and scale it up just a bit, but we'll deal with getting it to the right size in a second. Once that's into the document, we see that we get a canvases folder added to our browser, and this particular image has been added. So if we right click on that and select calibrate, we have the opportunity to pick 2 points, and the further away those points are from one another, the more accurate it's going to be. So between these 2 points here, the length is 1214mm. So now the whole image has been scaled roughly to that size. If we draw a center point rectangle, from there out we know that it's 1214 wide. If we press tab, we can go back to the other dimension and type in 800 and then enter twice, and we end up with our rectangle. How well does it align? It's pretty close. Alright, so that's pretty sweet. So how are we going to draw all these lines? Well, we can take advantage of that second option that I mentioned before, where we can select a whole bunch of points from a sketch. So let's create a whole bunch of points. We could do with, I'm going to add this to my ribbon just so I can keep coming back to it. I can place a couple of points, but are they really aligned? No, they're not. So how do I align those two so they stay horizontal? I have to hold down the control button on my keyboard, right click and select horizontal vertical. But I can't select a whole bunch of them at the same time to do that. I have to do them one at a time. So that's not going to be ideal either. That's far too much clicking. So let's undo those points and take advantage of this particular canvas that we've created. So can we see any trends here? We've got a rectangle, we've got some lines here. There's a rectangular pattern in the middle with another rectangle in here, an oddball set of 3 holes which are in line with one another, and another rectangle here. Looks like it's mirrored over this side. Right, so let's start drawing some lines. Can start roughly from here across to here. Repeat command and draw from here across to here. Alright, that's all good. And now let's do a rectangle. So half a rectangle, center point here across to there, and we want to do another one from here to here. And we'll grab this rectangle in here. Let's go back to press L for line and draw this line. And we're going to do these two lines out here as well, so repeat command. We'll draw a line from this kind of overall rectangle straight the way through to the other side. And do the same thing on this side. Now these are actually, there's 36mm on this side and 30mm on this side, so we can't mirror that, okay? Alright, so they're all individual lines, which is fine, but they are lines which end up being calculated for profile. So when we extrude this, we're going to have to select each individual profile here, so we don't really want to do that. You can see these profiles here now quite clearly. So let's highlight all of these and press X to turn them to construction lines. Okay, X, X, and X, leaving only the outside as a normal line. Okay. The other option there is to highlight that and just switch between normal and construction by clicking this option here. Alright, so we've got all of our construction lines laid out. Now we need to start placing some points. Now when we enact the whole command, endpoints of lines are treated as points. So we don't need to place points at those locations. So now we can start placing them. And notice here that I'm automatically snapping to that line. So by placing the next one, it's going to make sure that they are horizontal and in alignment with one another. We do need to place some additional holes in here. Now, I know that this, by looking at this, 85, 90, 85, 85, 90, 85, so we can snap to the midpoint of that line. Alright, so the little triangle icon came up indicating that. Then we need 2 more points here. This line here is 11 mils away from that, and on this side 11 mils away from that. So again, we can snap to the midpoint, and we don't need points on either end of the line here. These are kind of independent points, so we could pattern them, but just so I can show you the workflow, I'm going to place them manually. I don't need to place any points on here, nor on this rectangle, nor on this rectangle. I don't need any points at either end of this, but I can put one in the middle because we've got 47.5 mils either side, so it's definitely in the midpoint of that line. All of these holes here are going to be mirror image of this side, but we're just not going to select this particular hole because it doesn't exist on this side. And then all of these holes in the middle here are a pattern. I could pattern them from the bottom left corner across, but this particular hole is in alignment here, alright, with this one. So I'm going to place a hole there, place a point, sketch point there, and we need to do all these sketch points up the side here. So again, I'm snapping to the line to make sure they remain aligned at all times, and then the same thing over here. But how about this for a different method? Instead of placing individual points there, let's undo that. So Control Z. We know that the endpoints of lines are treated as endpoints. So let's make it easier on ourselves for constraining and just draw between these. So we can dimension once and only have to deal with one constraint. I'm going to leave them as normal lines because if they're construction, then I'm not going to be able to select the points. So D for dimension between that line here and the edge of the original rectangle we sketched out, and that's 50 mil. So that's it. This edge, this line, and this one here we've already discussed is 36 mils. This line, this set of row holes is 215 mils away from the previous set. These ones are 220. And then the last ones are 215 again. And so you can kind of see they're all falling roughly in the right place in regard to the image behind it. Just one last point is this one here before I forget it, and we may as well dimension this while we're here. So I pressed escape to exit the command, then D, to execute the dimension command, and this is 40.7 millimeters away from the edge, the top edge of the rectangle, and 576 away from that side of the rectangle. Notice that these lines are blue at the moment because these, although I've constrained it about the center, these are free to rotate around, so I'm just going to use the highlight both of those and then use the fix unfix. Now you can see everything's turned black, which is all hunky-dory. It's exactly what we want. We don't want this stuff floating around all over the place willy-nilly. Right, so we actually need to dimension this side here to tie that down, so that's 30 mils. And so that's all of our holes positioned down the side now. Now we can start tying this lot up. So this is 106.1 mils square. Alright, so let's highlight those two edges and make them equal to one another. Now we need to tie down the location of that whole rectangle, right? So D for dimension again. Dimension from that edge, it's 141. And then from here to the bottom edge of the rectangle, it's 182. Okay, so how about this bottom line here? We'll just start working our way up, right? This is 214.6, and the end point is 274.4 mils away. And the overall length of the line is 85 plus 85 plus 90 plus, then we times that by 2. So let's do some formulas here. So we'll add some brackets to make sure that that all gets calculated first, go to the end and then multiply it by 2. The use of the PDF underlay here has been quite handy because I've just noticed that one of these dimensions is wrong, and I wouldn't have noticed it if I didn't have the PDF behind this sketch. So actually this is 274.4 plus 11 mils, and then we dimension from that point there to this point here as that 11 mils. Okay, so that's tied down that line, and we're talking 14 mils away from each other here. And we want to tie down this end as well, and that's also, oh no, okay, what's going on here then? So why has that been locked down? Let's just delete this line a second and draw that one out again. Alright, so that's all fully constrained now. So how about this rectangle? So from there to the edge is 235. It's the same dimension on the top as well. 235. I could also make this equal to this. So if I change this one, so you can see the FX lettering at the front indicates that it's equal to this, to another dimension, and that's this particular one over here. Now how far away is this from the edge of the rectangle? 119.9. And what about this side? 194. Okay, right, the last couple of construction lines to dimension is this one here is 323.1 from this side across, 421.3. This is 90 mils, 112. This one is 47.5 times 2, 95 mils. And I just need to lock down the position of that to the side of the rectangle, 296.8, and then the position of the line from the top of the rectangle is 373.4. Alright, So let's turn this canvas off a second and have a look and see what we've got. We need to make sure that turn on the horizontal line constraint, that is vertically constrained to that. These two are vertically constrained, and then these are horizontally constrained to one another. Now they're just free to move up and down, and I know that they are 30 mils, so D for dimension from that line 30 mils away. And if we execute that horizontal vertical constraint again and make that vertically constrained to this point here and dimension this point from the top edge of the rectangle is 310 plus 60 plus 60 plus 60, because we've got 4 rows with 3 gaps. Alright, so let's do some patterning. Do a rectangular pattern. Going to pattern that object. We need to make sure it's the spaces in between. This horizontally is going to be symmetrical, and we want a total of 5 holes in a row with an offset of 143. We can turn off individual instances if we want, just by deselecting this checkbox here, so it will miss out this hole and place this one over here, which is pretty handy. But we do want that one on there. Then in the other direction we want a total number of 4 holes with an offset of 60, and that's the lot. Okay. Alright, so we did have a whole bunch of holes over the other side here as well, so we do need to mirror those, right? So L for line will snap to the midpoint of this rectangular edge over to this side, highlight the line and make it construction, and we'll execute the sketch mirror command, and we want this line, these 2 holes, this line, actually we need to add both of those, that point, and also this point here. Actually, just remember we need to get rid of this one, so hold down control of the keyboard and then click that to deselect it, and we need this to be mirrored over the other side as well, and that's the lot. So we just need to select the mirror line, everything's mirrored over this side, and we're ready to go. Alright, so how about actually placing some of these holes now? So we finished this sketch, we need to come back and press E to extrude this, and we'll extrude it away from the screen minus 10 millimeters. We have to turn this sketch back on because we need to reuse it now, right? And then press H for hole, and we'll start with all the tapped M6 holes in the middle. So we're going to select from sketch, and we can window select over all of these lines and points. Every single one of those are tapped M6, so we need the diameter to do 6, extents all, so it's going through the whole thing, right? So we orbit this around, you can see it's breaking through, and that's it. So we click OK, and just to keep track of things, if you right click on the feature and rename it, we'll go tapped M6, enter. Alright, so that's those holes done. We'll look at the top of the part again, and press H for the next set of holes. So these are all 5mm diameter holes, and the same here as well. So with depth through all, diameter 5, just check that they're all going through, and they are. Click OK, and we're done. So those holes are done. Right click, look at the top again, press H for hole. This time we're going to do these tapped M8s, no, tapped M10s, 10 mils, going all the way through. OK, right click, rename, enter, and we need to do these holes down the side here. So H for hole, we'll window select over the endpoints here, and these endpoints here, and these are just 8mm through holes. So H again, select that one hole, set it as 12. Okay. and then H again. This time we're going to select those two holes, these two holes, and we're changing to a countable this time. Right, so the countable depth, let's just call it 4 mil. The diameter here is 42. No, we'll go with 38 and then 42 on the countable diameter. That's it. Okay. We turn that sketch off. We've now got all of the holes we needed in that plate, and it's all parametric, so we can go back into that sketch at any point and edit the patterns or edit the overall sizes of the rectangles and their positions, and everything will just update. You know, that was a reasonable number of holes, fairly complex sketch to dimension and layout, but we've now got a fully parametric model with all of the holes in it for this fixture plate in around 20 minutes. Now you can step into the CAM environment, create a setup, and let's say drill, we can go with a 5.2 mil drill in this hole, select same diameter, and it's going to go through and find all of those holes and machine them in order. Then we could right click, duplicate, edit this, switch to a tap, and go with an M6 tap, and now we're tapping all those holes as well. Right, well, thanks for tuning in today. I hope that was helpful, and I'll see you again next time. Cheers guys, bye.